All right, welcome guys. Mike Rossell here, Engineers for Communities. Got a really great episode today. We're going to be talking about how AI is being used in revolutionizing infrastructure management. We've got a expert in the field who's actively out there working in it, Matt Stahl, who works at Halff. He's a team leader and he has quite a few different case studies and interesting background to talk about it. Welcome to the show, Matt.
Thanks, Mike. Glad to be here.
So give quickly, how does someone tell us your journey to starting to implement AI into infrastructure management? Like, where did you start learning?
So I've always been kind of a data guy. I'm a professional engineer and focused in water resources through my career, but I've always kind of gravitated towards data, databases, GIS, just all the information that's kind of contained behind the scenes. It's always been fascinating to me. And so really I got started in hydraulic modeling, and from there transitioned into more infrastructure related work, asset management. And about 4 years ago, I was at an asset management training actually, and kind of heard for the first time about artificial intelligence and machine learning and how it was going to change the world and really revolutionize, especially the infrastructure space. And so just started learning about it. I had some Python background, so started digging into how in the world could we apply this stuff? How could it add value? Does it add value? Yeah, I've been kind of going down that rabbit hole ever since.
So why would people so it's kind of complicated to understand and for other people to understand. When they think AI, they think chat GPT, like you're talking to something. But when you're talking infrastructure management, what kind of steps, or what would the word be? Like what are the tasks that it's doing? It's not, it's not a language-based model. What how would you describe it?
Yeah, good question. So yeah, I thought about preparing an obligatory chat GPT joke, ask chat GPT what I should say to start the podcast off today. I didn't do that. But you're right. It's what we're using AI for is different than the large language models like chat GPT. I'd say big picture, what we're using AI for is either to classify things, kind of trying to say what bucket do you go into? Do you go into the good condition bucket, the poor condition bucket, the failure bucket? What pipe material is an asset? Is it concrete? Is it PVC? Is it clay? So we can classify that. That's one big usage of AI in infrastructure. The other is regression models, and everybody's heard of linear regression models, but what we mean by regression models in the context of AI ML is more a continuous numeric value. So if you have a score, if you have rainfall, if you have flooding depth, all those would be kind of regression applications of AI. So you're not trying to categorize anything, you're trying to really predict that numeric value.
Okay.
So most of the machine learning models especially fall into one of those two categories. The other big group, I would say, two big groups. One would be for computer vision. So computer vision is, it's a type of deep learning model, and instead of looking at tabular data that's already structured, we're taking unstructured data. So we're looking at photos, videos. You could look at audio files too, I suppose, but typically we generally work with videos and images, and so out of that unstructured data, we're trying to pull some structure, establish that structure at the pixel level. And so for those, we'll be looking for different objects of interest. So it might be for maybe an inventory application. It can be used, you can use those to get at condition. So we've done some of that with CCTV type of data. That's another big group. And then the last one would be geospatial AI. So it's kind of related to the computer vision, but instead of looking at specific videos and specific images, we're looking at very large files, so ortho imagery or satellite imagery, and
Wow.
out of that trying to look for those things we're interested in. be it land cover, be it classifying impervious surfaces or tree cover, dam embankments. You can really take it in a lot of different directions.
Wow, that I only came into this thinking about how it could be used to look at CCTV data and how it identifies like different cracks and breaks. I never thought about taking an aerial and you're able to, so you're essentially able to say this area is impervious. There's a some sort of dam here, and it can start figuring out areas, lengths, and help you kind of like start your mapping efforts even.
Yeah, definitely. Especially for those large data sets, it can be a really great tool. Caveat it with saying that those larger areas, larger larger project areas you might be working in, that's really the sweet spot for this type of technology. If it's a really a localized, smaller area that you're looking at, you could probably almost do it just as quickly manually. But if you go from, say 2 or 3 square miles up to 500, watershed scale types of things, that now you're talking like that. That's where these technologies can really, speed up your process.
So I got part of it that comes into play is like the level of detail you need. What is the level of detail that you're designing to, and how what it could get you to? Because like when I use something like ChatGPT, it never gets me 100% of the way there. It's always like, oh, that was super helpful. Thanks. It's like the level of like some guy out of school could give me, but he did a big part of the lift, formatted everything, got it in order, and then still had to take it to the finish line.
Yeah, and I'd say from in our experience so far, that really is the best role for AI at this point. I know it's going to improve, but models get better the more data that we add, the more representative they are of whatever system, whatever problem you're trying to evaluate. But that's where we are most comfortable using AI at this point, is to provide that initial list, that baseline, and freeing up the experts' time, freeing up the engineers' time for the more complex steps, further down the workflow. But like you said, that can be a huge time saver, just that initial lift, and
Does
task the computer with that and run it overnight on the weekends as needed. That can be a big time saver as well.
does it do you think of it, because I think of ChatGPT as someone like you can equip a C level student and upgrade them into a B. Are there uses like that as well, like saying, okay, or is it mostly you see it freeing up expert time? So you give it to an expert like user, like a PE, and he can use this. He doesn't need to then have his ZIT map out and draw all the different watersheds for him. In your example, he's able to just take it himself and keep running with it. Is that kind of what you're thinking?
I think there's room for that. Everybody's fear about AI taking our jobs and stuff like that. I guess maybe in this context that could be partially true in terms of taking over some of those initial tasks. So maybe instead of your team needing to have 3 or 4 people, maybe you have 2 or 3, and it could help perform some of those initial tasks.
I always look at it personally. I always look at it as we want to try to free up the experts' time because we want them to be able to have their hands on as much as possible because it's really hard to find that level of talent typically on a project. Would you kind of agree with that?
Yeah, I think so. I'd say, like your example with ChatGPT and the large language models, and so some of these large data set types of applications, I think those are, don't want to call them busy work, but they're things that it just, at the end of the day, it just takes time. You got to put the effort into to get the product you're developing or your deliverable. You got to put those hours in. So I think those types of applications of AI fall into that category. But the machine learning applications, which honestly is one of my most favorite type of AI model, I think it can help along those lines too. Taking lots of hours of effort that we would traditionally, have to invest and shortening that time frame. But more than that, they really do provide insight that I think in most cases we wouldn't have, like, even the expert, even as engineers, that's not where we excel, taking, these large amounts of data,
Yeah.
not just 4 or 5 different options that we might be looking at in scenarios, but 30, 40, 100 different attributes that all play in and all affect a question we're trying to answer. It's hard for a human to wrap our brains around that much information and synthesize it, but these types of models are really good at that.
So explain to me a little more. So I get what you're saying. When I'm working on a project, there's so many inputs, and sometimes you have to choose that some of these inputs aren't worth taking into account, like in your reasoning. Are you saying that these models, they could like give weighted scores to those, even those more minor things that you're not really thinking about?
Exactly. Yeah, and something we may get in today, get into talking a little bit about today, are the tree-based models, which is something that it's one of the types of machine learning models that's out there. But tree-based models and other machine learning models, yes, that's exactly what they do. They essentially are taking multiple different inputs, predictor variables. If you think about it in terms of x's and y's, with your x's being all of the potential independent variables that impact your question, your dependent variable, your y, all of those x's, any one of them by themselves, in a pipe context, material or age or soil type or traffic loading, any of those things all by itself, yeah, you might be able to find some correlations and things, but probably it's going to be a pretty weak predictor all by itself. But what these models do is they take all these multiple weak predictors and assemble them together and convert that into a strong predictor. And so, yes, they can take sort of these very small nuances that we would think would be related, or in some cases they turn out to not be particularly related, to the failure, to the condition estimation, to whatever it is you're trying to forecast.
So is it in so does it come out in an output of a score or like a grade, and then you as the model creator assign different weights to it? Does it know based on past models how much to weight? Like saying, oh, we had all this other data and these things were correlated to this problem, so it should be weighted more. Does that make sense? It's kind of a vague question, but
Yeah, no, that is a good question in terms of how the weights and the coefficients are derived. And then the answer to that really is those are generated by the algorithm itself. Like that's what the algorithm does, is to establish what those weights and coefficients should be, looking at past examples, looking at that training data that typically is historical information, whether it's work orders, whether it's condition assessment data, it's all those past events. So you have to have enough of that, but based on that past information, that's what the model is going to do, is establish those weights and coefficients, and then the output that most often is a probability. And so one of my favorite movie series is The Matrix, and one of the lines I always like to think of from first movie, I want to say, is, it's the question that drives us. It's the question. It's all about how you frame your question, right? So that's actually a pretty important part of machine learning, in framing and defining the question that you want to answer, and setting up the model to help give you insight into that question. But typically, it's a probability.
so can you walk me through maybe even an example so that people might be able to understand what an example is and what are all the inputs you throw in? I know you do some stormwater pipe management.
Right?
What are the inputs for something like that?
So inputs, they're typically going to fall into a few categories, and you can imagine kind of these models that they work, like if we use the decision tree example, tree-based models, they look a lot like sort of an inverted family tree, if you will. So you've got all these inputs, all these sort of branches and forks, and they're sort of really broad at the top, like a upside down pyramid, and they're converging down to that solution that you're interested in at the bottom. And so some of those different decision points, they'd be things like demographics, They'd be, property values, appraisal district type of information, different variables describing the land use, the soil types, physical characteristics of the area, as well as if you're talking about a pipe network,
Yeah.
as much information as you can find about those pipes, their physical characteristics.
So
And
that those are what you're talking about, the 50 inputs when you're saying if I'm doing some sort of asset management plan or a capital improvement plan, it's really hard for me to help score and weight decisions based on zoning, land use, like maybe looking at the soil map, also adding in like what's the income in the area, what kind of businesses, what's the property value, like you're trying to like add all those things into the decision process, which a lot of times just get kind of passed over.
exactly, yeah, you're able to, with these models, you're able to really harness all of that information. Where for you or I, or both of us put together, it would be just too much to try
Right.
to wrap our brains around. We know that at some level all those things are at least loosely related, to the outcome, but it's just hard to tell how and to what extent and how much each one should be weighted. But the models are very good at that, and what they do as part of the modeling process, you end up with a feature importance output for most of the models. And what that looks like is just kind of a simple bar graph. And it basically will tell you, according to the model the data that you provided to your model, and the subset that you're looking at. And these models only know what you show them, of course. So you always have to remember that. But based on the data that you provided, those inputs, it'll basically come back to you with, okay, well, based on these inputs and then this outcome that you're trying to predict, the very most important attribute is this one, and number 2, 3, 4, and it'll go on down, in order of kind of decreasing importance. And so typically you can kind of make a first cut, and use that type of output to help you establish, all right, here's my top 10 factors that are really driving this failure, this prediction that I'm trying to make. And using that, you can then filter down your inputs and actually end up getting a better model, kind of for that you would carry forward.
Meaning you would choose to remove some inputs from the model because they're so it's determined it's so minimal that it's not really worth including like in your end report kind of thing.
Exactly. Yeah, that's usually a best practice. You hear people talk about the dimensionality of their models, and you don't want a model that has too high dimensionality or too many factors, because although it may be very good at establishing kind of the all those weights and coefficients and the function that describes that failure, for instance, for that data set, as soon as you go and point it at unseen data, it's not going to do as well. So
Gotcha.
they refer to that as overfitting on your training data. But if you reduce your dimensionality, that can make your model less likely to overfit.
So you had mentioned about the computer vision for defect detections. I think you mentioned how you're training it to look at different CCTV data and or so I think that was specifically what we had talked about. Where are you guys? Have you guys already been using this, and who's benefit? Like, what's the benefit of it? Kind of give me the overall.
Yeah, so computer vision it's really neat stuff. It's really interesting. Essentially what it's doing, it's taking those videos and images that are collected, say, through CCTV, but you can really, any of that type of data source you can use. And we train the model. We go through and essentially label ourselves lots and lots and lots of examples of the different defects they're interested in. So, in a storm drain pipe, that would be your cracks, your offset joints, your holes, pipe collapses, debris in the pipe, anything and everything that's a problem in the pipes. And that typically our contractors do a really good job of identifying those different observations and calling them out. But you still have that human error, right? That's hard to get away from that. And so these models, once they're trained on enough of that type of data, enough examples, enough variety, they can then be applied on new data that comes in and find those same objects and really do a pretty good job of it. And so, like we were talking about with data sets and providing a baseline of information, the same really applies for CCTV and this sort of semi-automated defect detection. That it does a great job, and it can do it at night, on the weekends, and in the background. But we don't feel at this point that that is ready to take the engineer out of the loop, take the domain expert out of the loop. But it does provide a great baseline. It can point the expert where they should focus, where they should take that deeper dive to find those issues that need corrective action.
I can tell you as an EIT, I've spent, I don't know if it's quite hundreds, but tens of hours watching TV data, just back checking contractor work. And the thought of saying, okay, the contractors created a report, let's have this tool like create its own little breakdown that it works asynchronously, so it's not affecting like your and your resources, ability to work. I can say that that's exciting. At least it doesn't remove from doing it, but it's definitely something on the engineer side you can use to quickly like just scrape their film, right?
Exactly, and that's exactly how we're using it as a QA/QC tool. We, on all of our projects and all the programs we work with, we have a pretty robust QA/QC process in place, so that this is in no way replacing that. But most QA/QC for projects like you're mentioning, it's tough to have kind of the scope and the budget and just the resources to manually review everything, right? So I think most people will go through a process of looking at subsets, 15, 20% maybe. And if you find more errors, you ramp that up. And, if you're not finding as many errors, that level might be sufficient, but it's a subset. So there's still that risk of, is there something we've missed? And
Right.
honestly, that's how we got started with computer vision, was having a few of those, near miss types of experiences and some things that did get missed, kind of that in that 5% human error category, which a lot of the time, even that 5%, you could probably boil that down into 2 to 3% of the 5%, so it's a very small fraction. But if it's the wrong fraction, man,
Yeah.
it could really cause, huge safety issues. It could be very expensive to repair under emergency circumstances. And that's the thing with these technologies. The big benefit, aside from decision support, is just helping municipalities and utilities to get out in front of these issues that are in their system. They're out there, but using these tools as a way to augment their knowledge about the system, where the problems are, what needs to be fixed, and trying to do that before the sinkhole opens up, before the collapse happens.
You showed me some
That's
pretty gnarly pictures of cars and pretty massive sinkholes in some of your presentations.
Yeah, in fact, there was a, a really serious one. Luckily, no one was hurt, but over near Montgomery Plaza in Fort Worth, 7th Street and Carroll, there was a big driver for Fort Worth program was a sinkhole that opened up there. And yeah, those things can be pretty dangerous.
So, I'm not an expert in sinkholes. So, do sinkholes typically happen when you have large pipes collapse underneath them, or some sort of large void area collapsing?
Yeah, it's usually the thing about sinkholes and those void spaces, they don't happen overnight, right? It's a progressive, kind of deterioration. There's a lot of factors involved. But yes, typically there's a void that forms. Yeah, so you've got soil movement, you've got backfill and embedment that, in some cases maybe it was installed wrong, but for whatever reason that gets upset and a void forms. And over time, with pipes flowing full with high soil moisture levels, that sediment gets kind of eroded away. And as time goes on, it just gets worse. It doesn't usually get better. And so, yeah, at some point, just given the right kind of perfect storm of circumstances, that will develop into a sinkhole. And honestly, it really doesn't take a huge pipe. You'd think it would be a 72 inch or 120 inch, these really
Yeah,
large pipes.
that's what I would think.
We've seen these happen, on 36-inch pipes. So yeah, even the smaller diameter pipes can cause some pretty big problems.
Okay, so on the GIS side, I think I don't know if we really talked about it. Do you have models set up that can essentially take a GIS database as is, and you can plug it in and it can identify what are like critical? Would it take that GIS database and be able to identify like where your critical segments of your pipe? Wow, I cannot speak today. I think you know what I'm saying.
Yeah. I know where you're going with that. Yes, for sure. And GIS is a great data source. We continue to find, really time and again, that all of the data we work with, all the systems we work with, really as engineers in general, but especially in infrastructure, it all has a spatial component. So we really can't get away from that. But the great thing about GIS and having information in that kind of spatial context is there's so much you can do with it, right? And granted, nobody's GIS is perfect, so that is a challenge. But between the attribute information, material, age, size, alignment, all those kind of basic attributes of pipeline systems, and then really expanding beyond that into looking at the relationship of those underground assets, horizontal or vertical assets, whatever type of system you're looking at, stormwater, sanitary water, it really all applies. And these models can be applied effectively for all the systems. You can look at the relationship of those assets to, to other utilities, to soil groups,
Right.
to
Kind of
development
like what you're
density.
mentioning.
And all of those are they're very instructive kind of inputs for these models.
Well, yeah, so is that kind of, I'm trying to picture for the end user. So they have their GIS database already, and a lot of times I think they've got lots of other shape files that have a lot of that data as well. That may not be that database for their storm pipe, but it's all spatially in the same area. So are
Right.
you saying you're able to take a lot of those different, their shape, I mean, I'm going to call them shape files, but those shape file databases, and like is that kind of what you're doing, is those are the inputs you're talking about?
Exactly. Yeah, you can almost think of it like, multiple layers. I mean, that's what they call them in GIS, is layers, but in terms of for one given XY location, basically all of the different, shapefile layers and their associated attributes that are associated with that location. Yeah, all those are basically stacked on top of each other and used as inputs for these models. And here recently, just a plug for the Esri software, which I think probably most engineers and firms use. There's other softwares out there, of course, but that's the big one. They've come out with some pretty neat tools in some of their recent versions for doing this type of analysis, and it makes it easier, I'll say, to use those different layers. We typically still do most of our modeling outside of the GIS environment. I mean, the GIS piece is certainly important in terms of the data processing and the prep. But the actual modeling we'll generally do outside of that environment, just because it's faster. You have more configurability, more ability to dial in the models, make them better. You can do kind of a basic version right in GIS these days, which is great. But for kind of some of the more advanced stuff, there's more room for customization, in a coding environment like Python or R.
Oh, like you have the more flexibility to put if then statements, stuff that really kind of just build a little further than what you're able to do in GIS.
Yeah, like logic, just kind of building, rolling the code the way you want to roll it. You can, yeah, you definitely have more flexibility to do that. But I'd say even beyond that, actually using the models, there's a lot of parameters that the models have, similar to maybe a hydraulic model. Lots of things you can tweak and that you need to tweak in many cases to to really set the models up properly. And in the GIS environment, you get kind of the default parameters for those. And as long as those fit your case, that might work. But yeah, you just have a lot more flexibility when you kind of take the data from GIS, but then push that tabular format out to one of those coding platforms.
Would a piece of data be like, I think of like a road, if you're trying to figure out how important is the road that this pipe sits under. And there's many ways to look at that, but you could say if it has this many trips, if you've already got traffic data for it, you know how many cars are traveling. Would that be an example of where you'd want to pull it out of your GIS database, put it into this other software so it can start breaking down different, like essentially class levels and how busy that road is and adding a weighted score to that?
Yeah, so Mike, you're sounding like a budding machine learning engineer. So that's exactly what we would call the feature engineering step, kind of the modeling process. It starts out with exploratory data analysis or EDA, and then it goes into this feature engineering, which you're starting our feature engineering on this hypothetical case, and then it gets into the modeling and model refinement and prediction. But yes, for feature engineering, that's actually the kind of the secret sauce, I think, for machine learning modeling. It's these models, they're really cool, they're flashy. There's lots of algorithms with funny names, and those are all available and can be tweaked and tuned. But really, the secret is in the data, and specifically in which features, which attributes you supply to the model. And that's really what makes or breaks a poor model from a good model. And so
Well, and
yeah.
was that kind of what you're saying is right? Like, I feel like if I was trying to determine how critical a roadway was, and if that pipe broke under it, like let's just say we're looking at all the water lines, and I want to know, well, if this water line breaks, what's it going to affect? And the road's going to be shut down because they're going to be doing it. That would probably be pretty important if it was, if it was the Dallas North Tollway or something. Whereas if it's some rural road that's only got 100 cars a day versus tens of thousands of cars, it's just going to get weighted differently. But maybe
Definitely.
something like, I don't know. I'm trying to think of like what would be an arbitrary piece of data that would make the model poor.
So what you're getting at, I think, would fit into the category of the consequence of failure. So like you're being under the busy road or being under a major highway, being under a railroad, serving a hospital, things like that. That would all be in that consequence of failure category. Typically, what we'll try to predict with machine learning models is that other side of the risk equation, the likelihood. But then we'll bring back in that consequence piece for the final prioritization, because the likelihood, that's really just a surrogate for condition, right? So it's whether you do it through a traditional kind of risk-based approach with just rules and risk criteria, not machine learning, but using those rules, it's the same thing. You're trying to predict that condition, but the consequence piece is super important. Those two really work together.
Okay,
Yeah.
so I are I guess what there are multiple layers. I totally skipped over it. So it sounds like you've got the risk, you've got the failure. What other data comes into like the ultimate report that you're working with?
So from an asset management perspective, I'd say that those two are really important, and those work together to provide that kind of business risk exposure. But beyond that, other factors, constructability. So we look at a lot of corrective actions that are needed in systems, and it might be the worst pipe out there, and really need an immediate response. But if we don't have an easement, if we don't have a right of way, if it's under someone's house,
Right.
all of those things can really, that constructability piece tends to push things over into a whole other category. Another one would be several of the systems we work in more and more these days have issues with utility intrusions. So franchise utilities, utility strikes, gas lines, fiber, all that stuff gets, will break through without, unintentionally. but it will cause problems in the gravity lines. And oftentimes they won't be discovered until an inspection takes place. And you know that the storm drain was there first, right? Because in most cases, but those two can, put things into sort of a little pipe purgatory.
Yeah, no, I see it all the time, like a sewer line with just fiber cables or whatever just bored straight through it.
Yep. And whose utility is it? And working through that whole process can be pretty time consuming. But yeah, I'd say those are the big ones: the likelihood, the consequence, the constructability. Probably the last one would be other project opportunities. If you know, if the road where your number one ranked pipe repair, if it's going to be repaved next year, well, shoot, might as well wait on that and kind of bundle it all together. So given coordination, kind of amongst utilities, there's opportunities like that.
So the big use of the AI in the asset management is the biggest part's the risk component that that you guys have really developed. But in terms of the other portions, is there a lot of progress being made? I guess I'm just trying to understand all the different components.
So I guess you're asking, is there applications for AI in constructability and in some of
Yeah,
the
I'm just curious because, right, like a lot of these things you could put in an Excel spreadsheet, weight it, and then kind of move it all to the end. There's just so many inputs and so many different. You're looking for like different layers to your asset management plan. I was just curious what other layers you guys kind of have been that AI could potentially break through and do.
So I know there's plenty of them we haven't haven't even thought about yet, but I'd agree with that the risk piece, like especially the likelihood of failure, that condition aspect, that's probably the biggest application. Mainly because where the AI really shines is, it's these situations where we have, quote unquote big data, although our data is not usually as big as, the internet or something, but it's big to us, right? It's a lot of information to try to ingest. So it really shines for those cases of lots of inputs, lots of information. But the other area is, systems or assets that are challenging to inspect, costly to inspect. For whatever reason, it's not a simple thing to just go and take a look. Because if you can go take a look and get that information, like for roads, for example, PCI scores. Well, it's not free, but it's right there. You just drive the road, you have the right sensor, you collect the information, and boom. Like there's you could try to predict that, I suppose. There's applications there, but it might be more cost effective to just go collect the data and go on about your capital plan. So I think that's an important piece, is applying the AI like at that planning level, but especially in the applications that are, we're gathering that data otherwise would be difficult for whatever reason.
Okay, that's a really good example of saying, okay, so in the example you're talking about like the specifically the road surface, and a car will drive over it with a sensor and it'll tell you what condition the surface of the road's in. And you're look the AI may be able to, based on some of the other risk inputs, determine like this road's probably needing replacement or it's probably going to be good. Like there's a high chance that it's good. Is that kind of what you're getting at?
Yeah, that it's, I guess based on just the physical information and data, it's fairly straightforward to establish a priority when you have that information. Where the AI does a great job is, when it's either pretty costly to go and collect that additional information, or it's limited. Maybe we're at the beginning of our, asset management journey, and maybe our system is 5% inspected, but 95% not inspected. And we'd like to maximize our effort. And, maybe we've had a couple of sinkholes that opened up. So we'd love to, catch those sinkholes or water main failures or sanitary sewer failures, try to find those parts of the system, most like what we've already seen, and get out and lay eyes on those first so that we can fix them, prevent those catastrophic issues. So it's almost the application is to help direct where those condition assessment efforts are are going to add the most value. And I'd say one other sort of right in this train of thought that we're talking about, like where to apply the AI that it adds value, would be essentially from separating out like even if you do have the data, even if you have, say, in a condition assessment example, you have large diameter sanitary sewer lines and you have multi-sensor inspection. So you've gone to the effort and the expense, because that gets pricey, but for whatever reason you've decided that's warranted. You're maybe a large utility in the area, and you go to that, you collect that data, but it may be that you get back so much poor condition information that your problem is not trying to estimate what the condition is, but it's sifting through all of that
Yeah.
all that data that you do have. That's just it's the similar problem of so many inputs, but instead of in a predictive, let's forecast and go let's predict where the hotspots are so that we can inspect them. We have the condition assessment data, but everything's bad. So how to essentially sift through that. So that's another application we're looking at.
I have a great example that I'm working with someone I was going to ask you about. Is they're having a lot of sewer inflow. This is not a very large community. It's like 700 taps, but they've got 36,000 feet of sewer line. So like it's a lot of footage for them. And they've got no data except for some GIS map someone made, and that has like age of pipe and size. And someone came in and said, well, we should just smoke test the whole system. And I said, well, I mean, there's so many more reasons why not to just do something like that. You don't get a lot of data, like actual usable data out of that, meaning you know that there's a leak or not somewhere if the smoke's coming out of the ground, but you don't know how much, you don't know exactly where, like, kind of where. What would you like? First, what would you recommend to that person? I thought TVing the line would be more effective because you could like at least tabulate this data and be able to figure stuff out like that. What would you suggest in their case, and would AI be something that they should be looking at using to back check this data?
So it sounds like in this case, the main concern is I&I. That's their main complaint, is what are these sources of I&I, and trying to get out and correct them. So
Yes.
So that being the case, yeah, I mean, I would agree with you. In my experience, sounds like your experience as well, smoke testing can be kind of hit and miss. It depends a lot on soil conditions, moisture conditions. Like you pointed out, it doesn't give you lots of great, geospatial data. I mean, you see what you see, but in terms of kind of takeaways, I would tend to agree with you that CCTV combined with the sound locating technique, these radio beacons that can be mounted on the collar and essentially located topside. When you kind of activate the beacon, you find a defect or you find a potential source of I&I, those can all be marked. That combination we've found to be the best solution to what you're talking about. We have a project right now doing something similar, and yeah, at the end of the day, the client is going to end up with so much more, a much richer data set. Like I think there's a lot more value because, like you said, you get the CCTV. With the CCTV, you can find not only your defects, but you can linear reference those defects. So, and depending on what their GIS looks like, you might not have the alignment between the pipes, but theoretically they'd have access points, manholes and inlets,
Right.
manholes for a sanitary system. And so you could rough out kind of what that GIS looks like. I'd agree with you.
Yeah. No. That was just something interesting. And the reason I bring it up is because I feel like it's a very poorly informed area, but it's a very trending topic where you've got, especially not in the bigger like the bigger providers. Like the bigger providers are generally getting advice from you directly. The little guys, it's whatever guy walks in their door, they're gonna solve it with whatever solution they're used to solving the problem with, sadly, because they're not getting solid inputs. And so I always take that the reason I take that approach is because if we have really good data and we're able to structure it out, we can come up with a really good plan and we can figure out, like you were saying, where are the critical zones, what's the risk of failure, and make sense of it instead of being like, well, there's a leak here, we'll just fix that and this. And they don't understand that if you have a good plan, that's also kind of tied to your ability to get dollars, like low interest rate loans, potential grants, all those things. And so that's why like the better your data is and the better your presentation is, I think it opens up a whole spectrum of opportunities.
Yeah, and I haven't priced smoke testing here real recently, but I wouldn't be surprised if the CCTV was, not all that much more than smoke testing. So
I went out and got a few bids, and CCTVing is about 40% more expensive than smoke testing. But like I said, you can use it infinite times. Like that data is good for, I mean, people would say every 5 years you should TV segments of your line, but you could use it anytime in the next 10 years and it's still good.
definitely. Yeah, it gives you a nice snapshot in time of here's what everything looked like at this point.
Sorry to kind of run you off that. I was just
No,
kind
no.
of curious because I mean, you deal with a lot of these, and one of the things is to arm people with information so that they can reach out to groups like yourself and understand that it's not always what you're being told.
Well, and that's actually a good segue, Mike, into a point I wanted to make today is that although I get super excited about AI and all the possibilities and all the potential value that we can add to an insight into questions, the I'm all about AI. I think about it a lot. I'm actively working on developing it, but I want to point out that it's not always the best tool for the job. So, like in that example that you just mentioned, I think exactly what clients like that need to be doing is putting together a robust condition assessment plan, working that, building their GIS. That's the right tool for that job at this point. AI could come into play a little bit later on, perhaps. It could be used in a QC capacity for the CCTV, but just to make the point that AI is great, but it's important that we not treat it too much like a shiny object where it's the answer to everything, because it's really not.
I think of it like in AutoCAD, for example. They've got that scripting stuff in there, and it's like sometimes it can be great to help you do some things, but man, you can totally go down a rabbit hole, and you could have spent 10 hours trying to work with this, and it was a 2-hour task, and
Yes.
no one's going to be happy about that.
And I think a lot of people they're excited about AI and all the possibilities and everything, but it for a lot of clients especially, I think where their AI journey starts is thinking about how they'd like to apply it in the future, how they could apply it given the right data. But then based on that, performing a little bit of a data audit and looking at what data do we have, what data are we missing, what do we need to change about our data collection processes today, this year, in order to start collecting the right data. And oftentimes, like you may be familiar with the EPA's lead copper pipe rule revisions that have come out recently, and a lot of people are thinking about that, talking about it. There are some potential AI applications to help with that initial inventory, but one of the things that they do a good job of pointing out is that the data collection efforts should be part of normal operations, right? And so, in that example, looking at water service line material type on the public and on the private side of the meter, if a system is set up, if a framework is set up and it's enforced, used, existing staff, existing workflows can collect really good data that help in that application. And I think the same goes for a lot of utility, just day-to-day operations. Given the right framework, really good data can start to be collected now, so that 2, 3, 4 years from now, you have enough information to really do some of these predictive modeling types of things. But if you don't start
So,
it, you're never gonna you won't have that data available.
so I'll ask you this because when I'm collecting even data within my my business and trying to make decisions based on that, I always try to think of like, how wide do you want to make the data so that I can look at it at a very I can look at it very detailed. I've collected a bunch throughout the whole journey of a customer, maybe. I think something that's very relatable is like how people have built CRMs. And I know this isn't engineering, but when they build it, they start talking about all the touch points. They try to track every little thing that that person does, which
Mhm.
I think sometimes can be overkill. How do you educate your clients, potential clients, how wide their data sets need to be? Who comes up with that? Like, tell me more.
Yeah, that's certainly a challenge, and you make a good point about making striking that right balance between the breadth of the data, but efficiency, and trying to if it's your field operations crews or your equivalent of folks out in the field that are keeping the ship afloat and running in terms of your asset systems. You don't want to bog them down too much, and they need to have the right technology tools available. Whether those are phone based or tablet based, things like that. But yeah, that is a balancing act. I would say the sweet spot probably is to just take a strategic look at the data that you'd like to have, the data that you need, and try to simplify that as much as possible, so that you're getting that data, but not five times that amount of data.
Right. You don't want to be making more work in data collection that either a skilled person could use, actually you just use that time for otherwise as well, right? Is that kind of part of it?
Yeah, and if it becomes too cumbersome, people are going to start cutting corners. The, it's not going to be high quality data. So you always want it to be as high quality as possible, but be a pretty automated process in terms of at the end of the day, you come back to the office and there's a process in place to dock the phone, dock the tablet, like somehow get that information back into your master database, right? So if the phone gets run over or falls in a river, have it cloud based. The there's a lot of good data collection devices out there these days that facilitate a lot of that, and the photos and the media that might go along with that information. But yeah, there's so many great potential data sources out there.
Do you think of, I always think of the person that sets up the collection form, we'll call it in this case, is usually to to me, the data collection form has to be like the higher up of the modeling effort or whoever's going to end up using it because they know exactly what inputs have to be done. Like this is not a mid-level person to create these forms, is usually my experience. What do you think?
Yeah, I would agree with that. I think that the forum setup, and what's going to go into that, the content that typically needs to be kind of a community decision. Your different constituent groups that are involved, or that, like you said, would be using that data ultimately. They should definitely be a part of that conversation. Allowed to give input, allowed to, review, comment on that final form before it goes live. Yeah, no, 100% agree with that.
Okay, neat.
And also building in a training step, that piece we've also found to be pretty critical. You can have the the best laid plans, kind of thing, and if it's not, if the intent of that information and what you really mean by different inputs that you have on your form, that's not kind of communicated and transferred effectively, you may end up, whoever set the form up may think, oh, it's great, handed it off. Let's get a year or two down the road, and we're going to have all this data. Well, without that training piece,
Yeah.
something may be lost
Well,
in the translation.
no, I think you're right. I think of all the time that I try to set up any process ever, and I write it down, figure it out. It's in my head, and I'm like, oh, that's gonna work perfect. Everyone's gonna be able to understand this completely. I'm gonna get the outputs out of all this effort exactly the way I want. And then I find myself a month later, it's nowhere close, and we have to completely tweak it because, or maybe not completely, but there's definitely some key things that was missed or needs to be removed because it wasn't valuable.
And I would say that goes both ways, like on the data collector role on their side of things. there may be something about the data that's being requested that's completely unrealistic. It may seem like an easy piece of data to collect, but in truth, maybe maybe it takes an extra 30 minutes or so. Yeah, just
Yeah.
having some good dialogue about that is definitely a key to success.
Well, that's cool. I guess my last kind of question is, where do you see the future in this going? Because you talked a lot just now about everyone needs to be about how to collect it, because it's going to be better in the future. The capabilities are like exponentially growing. Where where do you ultimately see this going?
So, it goes without saying that the potential for AI, machine learning applications, it's huge. In terms of smart infrastructure integration, that's something at Halff that we're really focused on. Smart infrastructure, connected infrastructure, that has a lot of parts and pieces, but an important piece is the artificial intelligence. Asset management, we talked about some today. I think it has some really strong applications there. Digital data set development, we talked about that. We didn't get too much into like 3D and LiDAR scanning, but that also has some really exciting applications of these types of things. Flood prediction, that's really also an exciting area. It's an area we need to do more work on in terms of applying AI machine learning, but in terms of potential for preparedness and improvement of safety out in the community, and just swifter disaster response. I think there's some real opportunities there. We talked just briefly about the chat GPT types of models, large language models. So generative methods, generative AI, which chat GPT is an example of that. That's a brand new technology, a lot of buzz and discussion about it. But beyond just chatbots like chat GPT, like Bard, like BERT, there's lots of other very concrete applications of generative AI for tabular data, for image data. And it's really a neat technology. It's kind of a dueling piano bar kind of thing, the way those work. You've got a discriminator and a generator. You've got that essentially battle against each other to improve the final data. Really neat stuff. But so kind of exploring those, yeah, I think there's lots of exciting
Yeah.
applications coming down the road.
Wow, that's really cool. I agree. I think it's hard to even be at, because there's just it's growing so fast, and like you said, they can battle again. You're talking about like using different models, I think, to battle against each other and help improve each other quicker than we can possibly train it. Is that what you were kind of saying?
Yeah, so that those some of the generative models, there's a thing called a generative adversarial network, which I think is the coolest name. The GANs, that's what they refer to. And yeah, it's this. You have one model that's generating sort of simulated data, and it's trained on your historical information, your existing information. So it's generating new data. Then you have this other model, the discriminator. It's a little bit like an art critic, maybe, a food critic trying to really pick apart. It's a little a Jekyll and Hyde kind of situation, but the discriminator its job is to establish which of the data is real and which is false. And yeah, you put those together and they just end up with a better outcome than maybe the generator type model would have all by itself. But
Neat. Well, we are over time. I Any closing remark? And pick your brain, work with your AI-driven asset management things.
yeah, I'm always happy to talk asset management, talk AI, talk infrastructure. I'm up here in our Half Fort Worth office, North Fort Worth. So yeah, you can certainly reach out to me on LinkedIn. And yeah, I'm always interested in talking about new problems, new potential applications, business cases that are out there. And if you're a potential client, that's great. If you're a colleague, you're digging into these kinds of problems as well. I'd love to dialogue with you.
All right,
But
sweet, Matt.
Mike, I really appreciate the opportunity to
Yeah,
join you here today and talk through some of these things. Definitely been a
yeah,
fun conversation.
yeah, man. I really appreciate you coming on and educating everyone about the different uses, I think it's really a big field that I think in the next 5 years, like you're saying, it's going to be massively growing. And getting your data is probably the most important part because there's lots of aging infrastructure out there. So how can we find tools like the AI options to figure out where we should be spending our dollars, how we should be categorizing it? I think you've really brought up some great points today.
Yeah, I appreciate it, Mike. Yeah, I think for most people, like we were talking about, if you already have a fair amount of historical data, especially condition data, work order data, your information about your system is might not be perfect, but it's largely in GIS. You probably are ready to be able to do some of these things, predictive modeling and forecasting. If you're not at that point yet, that's totally okay. But like we were discussing, this is a great point to just evaluate what you do have, evaluate your data collection practices, your staff resources, and kind of use this as an impetus maybe to what would you like to have here
Yeah,
down the road, near future, and what can you change to collect that data,
and get to that point to
building,
utilize these
collecting the
tools.
right data.
Yeah,
Yep.
sweet. All right. Well, Matt, thank you very much. We enjoyed having you on the show today.
Great. Thank you so much, Mike. Have a
All
good
right.
day. Thanks, everybody.